Hey class, today what we're going to learn about is function notation. Function notation is just another way to write different relationships that we have, including linear relationships. We'll talk about quadratic relationships as well as exponential relationships later on in this course. But for right now, we'll just look at linear relationships. Our first example is going to be f of x equals 1 minus 2 times x. This is always going to be read f of x. This could be listed as another letter like g of x, q of x. It can be whatever letter you want to. But what it basically means is f of x is our output. Sometimes you'll see f of x. We kind of interchange f of x and y. They're kind of the same thing. And then x is our input. So whenever we do this example of we want to find, let's say, f of 2. What this means is that 2 is equal to x. So every time you see this 2, it's now replaced with the x. So in our equation, we had f of x, and then we had 1 minus 2 times x. So now this is f of 2. So what we do is sub in 2. Just simplify that following your order of operations. We got 1 minus 4 is equal to negative 3. Works the same as if I do f of negative 1. Sub in the negative 1, multiply, get minus a negative. Remember, minus a negative makes it a plus, so that gives you positive 3. And then we get, if we sub in a 0 for x, that's 2 times 0. So 1 minus 0 is equal to 0. So that's just the basics of function notation. We can also apply this to a graph. And usually the first thing we're going to look at whenever we see a graph is we need to find our domain and our range. Now, if you remember from our vocabulary words, domain represents the set of all the x values. So what you want to look at is our x-axis. We're looking here, and if you notice, our graph touches here at 0. If you go all the way through, this is a continuous graph, so there's no gaps, and it finishes at 12. So the way that we would write that is it starts at 0. We say that it's less than or equal to x, because remember that's our domain, that's our inputs, that's our x values, is less than or equal to 12. So 12 is the most that it can be, and that's if we're looking at just our x values, so right here. Now for the range, that's the set of all the y values. So now we're going to kind of flip what we're looking at, and we're looking at the y values as they go across. So I'm going to look at my lowest point to my highest point. Looks like my highest point is 6, my lowest point is 0. So, and I'm using my y because it's the range, that's the set of all the outputs, less than or equal to 6. So that's how we would represent the range. Make sure you do these inequalities will always face that same direction. Domain will always go with your x, range will always go with your y. And that makes sure that we get all of the numbers in between 0 and 6, even like 1.5, because even if you go to your range of 1.5, you go across here, you see that that is a part of our graph. Now if you went up here to 8, go across, you don't see anything a part of that. So anything below 0 or above 6, that's not going to be in our range of our data. So now that we figure out the domain and the range, we know that all of our answers are going to either be between 0 and 12 for any x, and between 0 and 6 for any y, and that can be kind of how you check to make sure you got the right answer. So whenever we do g of 0, this is our function g, it kind of curves a bunch. So what this is telling us is what our x value is. So you go find your x value along our x-axis. This is my 0 point. You go up to where it hits the graph and you figure out what the output is. So if I go from 0, go up, hit the dot, hit the line, and I wrote it, see that it hits 3. So my g of 0 is equal to 3. Okay, do the same thing for g of 4. So I'm going to go to where my x is equal to 4. So that's right here. I'm going to go up, hit my graph. Looks like it hits about right there. Go over. That's going to be 6. And then g of 6, go over here to where 6 is, go up, hit my graph, go over to my output, and that's going to be equal to 1. So that one's pretty straightforward. Anytime the number that's inside the 0, that represents the x. It's not multiplication, it's just saying what the x value is. And this question is a little bit different. So this says find the x values for which g of x is equal to 4. Now, if you remember back to the first slide where we could interchange f of x with y, this is the same thing. So g of x can be substituted for y. So what this is saying is that y is equal to 4. And what we have to do is come up with the x values. So we go to our output now, because that's our y's. Go across, see where it hits, and then go down so it looks like it hits 3. So one of our answers will be x equals 3. Now there may be some more if you look across here. So 4 hits there. It also hits here. And if we look down at 4, it looks like that's 4.5. So we'll just put a little comma, 4.5. And then it looks like way out here at the end, it's also going to be 12. So there's actually 3 answers for that one. But that's how that works. So remember, g of x, whenever that's equal to this number, you're finding the x values or what's inside the parentheses. Whereas if it's giving you what's inside the parentheses, that's the x values, and we need to find what the y is based on our graph. And that's it for function notation.